Good day, class. Since we'll finish discussing all about this differentiation stuff and limits, let's now proceed to a little more complicated or more difficult topics in differentiation, which is, of course, yung application natin and the related rates optimization and this extrema of values. So before that, before we proceed with the application itself, let's have some discussion about extrema of values first. So when we say extrema of values or these extreme values, we refer to the properties of a graph or a function. So in this topic, i-describe natin yung function as something na we can actually give an image of that certain function. For example, this polynomial function has a lot of bumps, curves, hills, and valleys, something like that. So in this topic, we'll be able to understand how it works, how can we find those values on a certain function. This topic is also not limited to finding the extreme values only, but also giving some insights on how this graph works or how this function behaves, if it's decreasing or increasing, or it's not actually it's neither decreasing or decreasing. And of course, discuss din natin dito kung paano natin ma-apply yung mga napag-aralan natin before sa geometry and sa analytic geometry, and of course dun sa mga basic algebra natin kung paano hanapin yung mga roots and then critical points, and also the division, and of course most importantly dito yung ating paggamit ng calculator, kasi syempre minsan kasi nane-neglect yung paggamit ng calculator in a way na pwede naman ma-simplify yung computations, but since hindi siya ginamit, so ayun, sayang, dapat nakasave tayo ng time. So with that, let's try to analyze these graphs so that we can pinpoint those parts and of course the locations of our critical points, these maximum, minimum, and relative minimum. So I will be discussing as I flash the figures and yung mga graphs natin para mas mag-guess nyo kung paano siya hinahana. Okay? Okay, so para mas maintindihan natin yung lesson tungkol dito sa extrema of a function, so meron akong iba't iba dito mga graphical representation of a certain function. So basically, itong function na to, hindi ko naman alam kung ano ba talaga equation, but ang gagawin natin dito is identify natin yung mga points na yan so that by just inspection, you can understand what are these global extrema or local extrema. Kasi mas mabuti maintindihan natin kung ano ba yung hitsura niya sa graph bago natin isolve yung mga values natin. Okay? So the first question is, what is or are the absolute or global extremum or extrema? Identify each. So by the way, I just want to reiterate that we have the same notation for absolute or global extrema mean the same thing. So when we say absolute or global, I'm referring to the same idea, that I'm referring to the highest or the lowest value in a certain graph. And extremum is the singular and extrema is the plural. So basically, this question is asking if we do have something like absolute or global extrema. And in this case, let's look at the graph. So, di ba pag sinabi natin absolute or global, that is the highest or the lowest value. So, if we look here, technically, when we want to look at the absolute or global extrema, you just have to find the highest or the lowest point on the graph. And in this case, that's F for the lowest and I for the highest. So, in this case, the answer would be F and I. So I have F, which is, this is the global, so this one is the global minimum. So that's what it's meant by this identify each. I-identify natin kung ano ba kung anong type ng extrema siya. Kasi remember, extrema is a collective term for minimum and maximum. So in this case, that's global minimum, and then I would be our global or absolute maximum. So you can also use absolute for such case. So, I hope malinaw yon. So, F and I, simply because yun yung lowest and then yun yung highest. Now, the next question would be, what is or are the relative or local extremum or extrema? Identify each. So, in this case, when we talk about relative or local extremum or extrema, those are the points in the graph. Siyempre, yung graph natin dapat continuous yan ha, meaning wala siyang breaks or gaps, no? So, when we talk about this relative or local extremum, it is basically the point in a continuous graph wherein it is not the highest point, but it is a critical point. Okay? Or it is not the lowest point, yet it is a critical point. So, when we talk about this critical point, let's say I have f of x, and then I took the first derivative of this function, and then I set it equal to 0. So, you'll be able to get a value for x in this case. Just equate it to 0 and then find the value of x. So, any value na makukuha natin dito from this general expression would be called a critical point. Okay? And then this, critical point can either be a relative or local extremum. In the same way that if we take the derivative of this function and then equate it to or make it undefined. So, any rational expression that can be differentiated, and then pag inequate natin sa undefined, meaning yung denominator magiging 0, then kung ano yung value ng x doon, yun is another critical point. So, there are two ways that we can determine the critical point. So, ito lang yung ways. Actually, nasagot ko na yung number 6 problem, which is how do you determine the critical points. So, ang gagawin mo lang is just take the first derivative, equate it to 0, find x. And then for the other one, f prime x, equate mo siya sa undefined. So, ito applicable lang siya for expression na pwede magkaroon ng undefined, that is kapag may rational tayong expression. And then, yun, pag nahanap natin yung x, meron tayong critical points. So, ang importance kasi nitong critical points ito sa relative or local extremum is that any local or relative extrema is a critical point. So, remember that. So, in this case, by inspection, you can see here that the relative or local extremum is a point in the graph that is something like a global maximum or minimum, pero hindi sila yung highest or hindi sila yung lowest. So, in this case, I can say that B is a relative extrema or relative minimum because it has something like a valley. So, ang valley na tinutukoy natin is ito, diba? Para siyang valley. So, nag-change ng concavity, meaning nag-change to from going downwards, then naging upward. So, basically, nag-turn siya. So, this turning signifies a relative or local extremum because hindi siya yung highest. Pero, in case na naging highest siya or lowest, actually, it should be lowest. In case na mas bumaba pa tong B, let's say dito, then that will be called the global minimum instead of F being that one. So, in this case, since hindi naman nga siya yung global, then B is one of the local extrema. And let's try to find another one. So, in this case, D is another simply because it is a hill. So, when we talk about hills, it's something like this, kasi para siyang bundok. So, hill yan. So, basta meron kayong turning point, so, kukonsider natin yun na local since hindi naman siya yung highest. Okay? And then, meron pa bang points ito? So, I think, wala na. So, ito namang C and E and H, di ba? Hindi naman sila nagkaroon ng turning points and they are neither hills nor valleys. So, B is our relative or local extremum. Actually, we should be using minimum. And then we have this relative, let me just write minimum, and then this one is the relative maximum. So, in cases, okay, I'll just give another example. So, I just wanted to say it na yung ating mga relative or local maximum, there can be more than 1. Okay? So, later on, baka may example ako dito. So, I'll just show you. But, hindi siya limited sa isa lang, no? Kaya nga, pwede siyang, kaya nga extrema yung tawag sa kanya eh. Hindi siya talaga strictly 1. Okay? But for the global or the absolute, usually, ito is 1 lang. Pero syempre, kung naging pantay sila, edi dalawa sila, no? Pero basically, ito is usually isa lang for global minimum and isa lang for global maximum. Usually, ganun. So, number 3 is, what are the inflection points? So, inflection points are also called flex. So, ito talaga yung totoong flex, diba? Inflection points exist in a way na kapag tinignan natin yung graph, it changes the concavity. So, when we say concavity, ito yung parang trend ng graph. For example, if it goes upward, then it concaves upward, and then kapag bumaba siya, so nagdi-decrease na yun. So, nag-change na ng concavity. So, yung inflection points, usually, makikita natin siya sa gitna ng ating relative or global maximum. Relative extrema or global extrema. So, in this case, meron tayong B and then meron tayong D, di ba? So, they are both extrema, meaning local lang naman sila. Pero, the thing is, they are both extrema. So, in between that, we can say that there's an inflection point. Simply because, di ba, ito pataas. And then, at some point here, nag-start na siyang mag-change ng concavity. Naging concave downward na siya. So, in that case, it's something like ganyan, and then, nagiging gano'n na siya. Okay? So, nag-change siya ng concavity, so C will qualify as an inflection point. Same as E. Okay? And then, of course, so, yan, E. And then, as well as H. Kasi, di ba, from C, E, and H. Kasi, kung makikita nyo, from increasing, then dito sa portion na ito, nag-start na siyang mag-change ng concavity. So, these are all inflection points. So, later on, mas mag-guess nyo kung paano kayo nahanap itong mga inflection points using mathematical methods na. But, in this case, I just want to show you how this works in graphical way para mas mag-guess nyo siya before we solve. Okay? And then, number 4, what is or are the saddle points? So, a saddle point is a stationary point na hindi siya local extrema and lalong hindi rin naman siya global extrema. So, if it's a stationary point, so, and then hindi naman siya ganon, hindi siya extrema. So, qualify siya as saddle point. So, kung siya is stationary point, we need to define what a stationary point is first. So, a stationary point is any point sa graph kung saan yung derivative niya is 0. So, diba these are the critical points, you can obtain them. And then, kung kakonsider lang natin is itong portion na to, which is kapag katinig natin yung first derivative and then sinet natin sa 0, yung value ng x, yun yung ating stationary point. So, ibig sabihin pala nun, kung meron tayong critical point, any stationary point is a critical point. It's just that yung critical points natin, meron pa siyang undefined dito. But if we're strictly talking about any value of x na magpapa-0 dun sa ating first derivative, then for sure that's a stationary point. Okay? And then, in this case, a saddle point can also be viewed as something that looks like a saddle. So, yung saddle natin, yun yung sa mga kabayo. Yung nilalagay natin doon, di ba? So, di ba yun na yung hugis pag ganon? Okay? So, doon nilalagay natin siya dyan. So, usually, itong mga gantong itsura natin sa ating mga horses, nilalagay natin para makasakay tayo. So, yun yung usually nagiging itsura ng ating saddle point. And ito yun, kung mapansin nyo, di ba? Ito yun. So, in this case, di ba, pataas yung ating graph. Pero dito sa point na to, hindi naman siya bumaba. So, it's still going upwards, but in a mas mababang dito, mas mababa yung slope niya compared dito sa pagtaas dito, diba? So, in that case, hindi tayo nag-change ng concavity until up to some point here. And then, dito na lang siya nag-change. So, in that case, we cannot say na ito is relative minimum or neither maximum kasi hindi naman nag-change tayo ng concavity. Nagmukha lang siyang saddle. So in that case, G will qualify as a saddle point. Okay, and then kung papansin nyo, wala na kayo makikitang something like that in our graph. And then for number 5, the next question would be, where is or are the stationary points? So when we talk about stationary points, again, yun yung any value na magpapa-zero sa ating expression here sa first derivative. So, sa totoo lang, ang stationary point, hindi natin siya kayang makita by inspection sa graph. Pero, we can actually give some assurance na mga points na sila is stationary point. So, a stationary point, sabi nga ulit natin, is the derivative of that, first derivative of that function at that point is 0. So, in this case, di ba, if we take the derivative at this point, makikita natin dito is, syempre, di ba, ang concavity nito is, this is the turning point of letter D, of point D. So, in that case, the slope of that particular point would be 0. And the same as well for letter B, for point B, and then, same din siya sa F, and then, of course, this I. And then, if we would also take a look at G, so any tangential line here would give us a slope that is equal to 0. So, any portion here na merong mga horizontal slope, that means 0. So, in that case, nagsasatisfy yun sa ating condition na yung ating stationary point would have a slope that is 0. So, in this case, I could for sure say that G, we also have F, B, and then D, and of course I are all, so we have B, D, F, G, and I being the stationary points for this particular graph. So, nasabi natin yon kasi nga yung ating slope at that point is equal to 0. So, magtataka, bakit alam ko na 0 siya? So, technically, kapag meron kayong hills and valleys, so, and then saddle point, usually, 0 na talaga yon. Pero, you have to take note that when the graph is changing abruptly, so, ibig sabihin yan, hindi na lang siya hills and valleys, no? Siya yung parang, mountain na gano'n. Kasi patusok, gano'n. Tsaka itong ganito. Hindi ko alam kung anong landform yan. So, once na makita kayo ng ganyan sa graph, instead of this smooth turning, it turns smoothly. So, if I would take the slope at this point dun sa tusok ng mga yan, so, is it logical to say that the slope here is actually also, yun nga, parang horizontal line? So, diba, the truth is, hindi to maging horizontal kasi basically, abrupt yung change niya. So, hindi ka nagkaroon ng slow turning point at that point. Hindi ka nagkaroon ng slow turning. So, ang nangyari dyan is, nag-change yung ating function abruptly at that certain point. So, in that case, the slope doesn't look like this one, which in turn becomes something like this. Okay? So, basically, pag nakita kayo ng ganyan sa graph, this kind of graph, can you tell that this is also a critical point? So the answer is yes, because sabi natin dito, ang critical points can either be if you take the first derivative, which is the slope, and then nag-zero siya, ang zero is itong horizontal, then that's a critical point. And it can also be undefined. And in this case, diba, any slope that is vertically drawn or vertical would mean that the slope is undefined. So in that case, this will qualify as a critical point. But of course, it's not a stationary point simply because it doesn't qualify with the condition that it should have a slope that is equal to 0. Okay, so I have to emphasize that. Okay, and then the last one is actually I've already mentioned this. So how do you determine the critical points? The answer should be around here. So Critical point is also called a critical number, and basically the critical point is the value of x, okay? And diba, since these are points at the graph on the xy plane, this x, of course, has a corresponding value of y. So the y here is called the critical value. Okay, so I know some books would give some, actually na-interchange na ibang books yan eh. Some say that the critical point is actually the xy coordinate, but most of the books that we use, especially yung nilagay ko nga sa inyong syllabus, would be using this critical point and critical number as the value of x only. So let's just stick with that notation. So remember, the critical point or critical number is just the value of x. When I ask for critical value, then I'm referring to the value of y and that certain function. Okay, so sana nag-gets nyo yung discussion about this 6 questions. So again, the global minimum or global maximum is any portion sa graph na siya yung highest and lowest. Then any point doon na naglalay in between this local minimum and maximum, I mean global or absolute extrema na nagkakaroon ng turning or let's say hills and valleys would qualify as relative or local. Then inflection point in between them, just changing the concavity, and then the saddle points would be those stationary points na hindi naman siya extrema. Okay? And then, of course, stationary points and critical points should be determined using mathematical methods. But by visual, you can also directly say that the answers here would be these points. Okay? So let's try number 2. I know medyo may idea na kayo kung paano siya ginagawa. So, try nyo sagutan yung number 1. So, the question is, what is or are the absolute or global extremum or extrema? Identify each. Okay? So, I'll give you 5 seconds. Just try to answer it. Okay. So, the absolute or global extrema for this function is actually is actually A and I. Okay? So, pag sinagot nyo is B and D, then mali kayo doon. Okay? So, bakit? Kasi kung titignan nyo pa rin yung graph, kahit hindi naman to yung hills and valleys natin, itong A and I, sila pa rin yung highest point and lowest point din sa graph. So, basically, yung A natin is our absolute minimum, and then I would be our absolute maximum. And these are collectively known as the endpoint extrema. Okay? So, I would just like to emphasize that the absolute or global extrema or extremum can also exist at the endpoint. So, how does that happen? No? So, if you have a function f of x and then you just want to graph it and then nilagay ko dito, let's say I have values of a, b, close interval. So, I have here, it should be around, let's make it negative a just to make it compliant with this graph. So, ayan, imagine nyo, meron siyang a and b. So, ang ginawa ko is, nirestrict ko yung ating function f of x with the values of the domain that's negative a and b. So, basically, kahit ito'y mahabang line or polynomial function na nag-extend all throughout the number line continuously, as long as I set the domain as any value, real number value. So, mapuputol yung graph natin doon. And then, basically, kung naputol doon and then yun na yung lowest or highest, then it can qualify still as the absolute or global extrema. Okay? So, I hope klaro tayo doon. So, ngayon, if your answer previously were B and D, and then mali ka doon kasi nga hindi naman siya yung global, so, technically, magko-qualify na ngayon siya sa relative or local. So, that's B, D, and of course, meron pa tayong F and G. So, wala na naman siguro kayong question regarding dun sa F and G kasi since kita-kita nyo naman na nagkaroon ng turning point and then hindi sila yung highest and lowest. Okay, so number 3, we have what are the inflection points? So, inflection points again are those points in between these local extrema or even global extrema. No? And then they can easily be found. Just look at these middle section of this extrema. So we get C, and I think it's E. And then there should be I think this point here H refers to the local minimum, and then I think I missed another point here for G, which is somewhere here. Yan. Para magkaroon tayo ng sagot doon sa ating inflection point for this F and H, which is actually G. Okay? So, ayan. So, baka magtaka kayo, sir, ba't po walang point dito sa between B and A? So basically, hindi naman kasi nag-change ng concavity yung ating graph from this section. No? Kasi, putol naman yung graph natin. Kung halimbawa, nadugtungan siya ng ganyan, then mag-change talaga siya ng concavity. But since it doesn't have any another parang local or extrema here, then hindi na natin kailangan lagyan pa ng other points here kasi hindi na siya nag-change ng concavity. So, we only have C, E, and G. And then number 4, what is or are the saddle points? So, the saddle points nga is, kung mapapansin nyo, mga ganyan tsura niya, o kaya it looks like this one. So, wala naman tayong saddle points here kasi define yung ating turning point in this graph. So, we have no saddle point. Okay? And then the last one is where is or are the stationary points. So again, yung stationary points natin, di ba? Pagka meron tayong derivative and then sinet natin to equal to 0 and then we find the value of x, then those are the stationary points. But to do this graphically, we try to find all the slope of the critical points, and then kung mag-0 siya doon, then yun yung ating stationary points. And in this case, I have actually 1, 2, 3, 4 of them. We have B, D, F, and then H. So basically, ito yung ating mga relative or local extrema. So, yung I and A, actually, hindi natin alam kung ano yung slope niyan. So basically, hindi natin pwedeng sabihin na stationary point siya. Pero, most probably, it is not kasi, kung mapansin nyo, parang putol naman yung graph natin. Pero, again, I would like to emphasize na hindi natin sure kung ito ba talaga is magzi-zero. Okay? And I would also like to emphasize na minsan nagkakaroon pa rin tayo ng zero dun sa ating inflection point. There are still cases like that. But most of the time, kung higher degree naman ating polynomial, so yung ating stationary points, usually sila yung nag-exist sa ating local and global extrema. Pero in this case, kung mapapansin nyo, the stationary point doesn't include these global extrema. So any of that doesn't hindi siya kasama dun sa stationary point. Okay, and then wala tayong saddle point. Okay, so kung mapapansin niyo yung difference dito sa una, so yon, and then take note of that, and then for the last one, I think ito na yon. Okay, so same questions pa rin. So the first one would be, what is or are the absolute or global extrema? Identify each. So, by the way, ito, mas kukunti yung kanyang mga points. Kung mapansin niyo, we only have 4 points here. Okay? And the first question is, what is or are the absolute global extrema? Identify each. Okay? So, I'll give you 5 seconds, probably, to answer this number 1 question. Okay, so if your answer is A and D, then you're wrong again. Okay, so but ganon. So the truth is, the answer here is that it has no global extrema. Okay, so again, pag dinefine nga natin yung absolute or global extrema, we refer to a point in the graph wherein, or a value of that function in which it is the highest or the lowest. And kung mapansin nyo, in this graph, we could say na A is a high value and D is a low value. But take a look at the end of this function. It extends upward, diba? And this one extends downward. So in that case, if that particular function extends, let's say for this f of x, if it extends upward, then ano ba yung highest value niya? Then probably you would say infinity. But again, infinity is not a value. It's just a mathematical expression that we use to give idea of how large a certain number is. So in this case, wala talaga tayong value for the extrema, for the highest value. So we have no global extremum. In the same way that this graph goes downwards, so basically bababa lang siya and then up to the very low value, parang negative infinity. But again, we need to find a certain value for that, and this infinity cannot give us that certain exact value. So in that case, wala din tayong global minimum or absolute minimum. Okay? So remember that. So sabi ko before, the global extrema usually just one, but it can also be more than one. But it can also be, but they can also be non-existent. So in that case, the global extrema can either be none, or it could be more than one. So yun lang, ang tricky doon. And then any portion here na hindi nag-qualify dun sa ating global would be considered local or relative. So yung sinabi niyo kanina, as if may sinabi kayo, no? So A and D would be considered relative extrema, and then for A, pag identify natin yung A, we have this one is a relative maximum, and then D would be a relative minimum. Okay? So for number 3, what are the inflection points? By the way, I didn't identify the points here. So B and F are relative maximum, and then D and H would be relative minimum. Okay, so going back, so number 3, what are the inflection points? So again, inflection points are in between those, usually in between those maximum or minimum. But in cases like this, you can always check on the concavity. So, di ba dito sa portion na to, pababa lang siya. And then, in this portion, pababa lang siya. But in this case, nag-start na siyang tumaas. So, nag-change na yung ating concavity from going downwards, downwards and going upwards. So, in this case, at this portion, we can say that this is an inflection point. Okay? And then, of course, kita-kita nyo naman dito, this is something like the opposite of that one that we have for number 1. So, this is a saddle point. That's B. And then the stationary points, again, we cannot determine it exactly by just inspection, but since we can see that these are hills and valleys, then we can likewise say that D and then of course A are, and then of course the saddle point. So usually this saddle point, any saddle point is actually a stationary point, so that would qualify. So we could say that A, B, and D are stationary points. So we cannot factor out C from this equation because we cannot know for sure if that's stationary, but most probably hindi yun stationary point. So yun. So I hope mas naintindihan niyo tong lesson na to by just graphic representation of how this global, relative, and then saddle point, and then critical point works. So again, I would like to emphasize that we start with a critical point. So again, yung critical point, makukuha natin siya if we set f prime of x equal to 0, and then of course f prime x equal to undefined. So any value that you would get will be called a critical point for this. And then yung critical point, kapag galing siya sa 0, pwede siyang, or siya mismo is a stationary point. Okay? And then this stationary point can either be global, it can either be global and then local. Okay? And then it can also qualify to being I'm sorry, a saddle point. Okay, so these are the three pathways of a stationary point. Can be global, local, or saddle. But of course, kung meron tayong critical point na undefined, it can also be something like global, and then it can also be a local, extrema, but hindi siya magiging saddle point. Okay, so ito yung mga possible pathways natin, starting from the critical point. So, ayun lang. And then, yung inflection point naman is separate, ano siya dito? Separate, parang entity siya dito, no? So, yung inflection point kasi, we obtain that by taking the second derivative and setting it equal to 0. So, any value of x would be the inflection point. So, that's the difference between critical and inflection point. Okay, so mas magagets ito pag nag-solve na tayo. But for now, let's just focus on the graphical solution for this. Okay, and in this midterm, you will learn how to graph certain polynomial functions and even those that are not polynomial, like say mix of a quadrat, a mix of trigo and polynomial, or basta kung ano man yung mag-qualify dun sa ating mga cases. Okay, so I hope mas nagets ito.